lecture series on probability. The main objective of this particular video lecture is to reduce the fear among the students for remembering the property statements, either through derivations or through any other manner. Property statements plays a crucial role. Sometimes you are asked to list the properties, and sometimes you are asked to prove the properties. So in such a context, how to remember these property statements we discuss. So general ga antam kada manam practice cheste edaina vastundi. Ivanni mundu chuse mundu mind lo em fix avvalante nenu nerchukuntunnanu, nenu exam baga rayali, నాకు స్కోర్ ఉండాలి అని ఒక మెయిన్ ఇంటెన్షన్ ఉండి చదువుతూ ఉంటే ఏ డెరివేషన్ అయినా కష్టం కాదు. ఒక ఎఫర్ట్, స్మాల్ ఎఫర్ట్. ఇది ఏం చేద్దామని అంటే ప్రాపర్టీ స్టేట్మెంట్స్ కంపేర్ చేసుకుంటూ జాగ్రత్తగా చేస్తూ ఈ లెక్చర్ అయిపోయేప్పటికీ PTSPలో ఉన్న ఫ్యూ ప్రాపర్టీస్ విచ్ ఆర్ ఇంపార్టెంట్ అది గుర్తుండిపోవాలి. అది ఆబ్జెక్టివ్. సో మీరేం చేస్తారంటే ఇది వినేటప్పుడు నా ఉద్దేశం ప్రకారం ఒక పేపర్ దగ్గర పెట్టుకుని స్టేట్మెంట్స్ చెప్పంగానే రాసేసుకుంటే చాలా ఈజీ అయిపోతుంది కదా. ఒక్కోసారి మనకి ఎగ్జామినేషన్కి టైం ఉండకపోవచ్చు, ఒకసారి మనం క్లాస్లో సరిగ్గా వినకపోవచ్చు, కంగారులో కావచ్చు, కన్ఫ్యూజన్లో కావచ్చు. సో ఆ పాయింట్స్ అన్ని దృష్టిలో పెట్టుకుని చేసిన చిన్న ఎఫర్ట్ ఇది. హోప్ ఇట్ విల్ హెల్ప్ యూ అండ్ లెట్ us స్టార్ట్. సో ఫస్ట్ మనం ఏం చేద్దామంటే టు బిగిన్ విత్ లెట్ us టాక్ అబౌట్ ప్రాపర్టీస్ ఆఫ్ properties of probability density function and distribution function. ఇవి జనరల్ గా ఇంట్రడక్షన్ టు PTSP లో మనకి స్టార్టింగ్ లో వస్తాయన్నమాట. ప్రాబబిలిటీ డెన్సిటీ అండ్ డిస్ట్రిబ్యూషన్ ఫంక్షన్స్. ఇక్కడ ఈ డిస్ట్రిబ్యూషన్ ఫంక్షన్ అండ్ డెన్సిటీ ఫంక్షన్ అసలు ఎందుకు అనేది ఇప్పుడు అవసరం లేదు, ఈ లెక్చర్ ఆబ్జెక్టివ్ అది కాదు కాబట్టి. కానీ ఒక మాట చెప్పుకుందాం, రియల్ టైంలో ఏది సర్టైన్ కాదు. ఒక రియల్ టైం సిగ్నల్ ఏదైనా ఉంది అంటే మనం దానిని చెప్పలేము, ఇలా ఉంటుంది ఇలా జరుగుతుంది కన్ఫర్మ్ గా చెప్పలేము. అది హార్ట్ రేట్ అయినా, టెంపరేచర్ అయినా, ప్రెషర్ అయినా, ఏజ్ అయినా, మన థింకింగ్ అయినా, ఏదైనా కానీ అది మారుతూ ఉంటుంది. ఏవైతే ర్యాండమ్ గా ఉంటాయో అలాంటి వాటిని మనం డిస్క్రైబ్ చేయాలి అంటే ఈ రెండు ఫంక్షన్స్ వాడతాము. ఒకటి డెన్సిటీ ఫంక్షన్, ఇంకొకటి డిస్ట్రిబ్యూషన్ ఫంక్షన్. అండర్స్టూడ్? వాట్ ఎవర్ థింగ్స్ విచ్ ఆర్ అన్సర్టైన్ ఫర్ డిస్క్రైబింగ్ దేర్ బిహేవియర్ we use a probability density function and distribution function. సో జనరల్గా ఏవైతే అట్లా మారుతాయో వాటిని మనము ఒక వాల్యూస్ ఇచ్చే ఫంక్షన్ ని ర్యాండమ్ వేరియబుల్ అంటాం. అది ఎక్స్ కావచ్చు, వై కావచ్చు. దాన్ని రిప్రజెంటేషన్ ఎలా చేస్తామంటే ఎక్స్ ఆఫ్ ఎస్ ఆర్ వై ఆఫ్ ఎస్ ఆర్ ఎక్స్ కామా వై కామా జెడ్ కామా ఎట్సెట్రా. సో ఈ రకంగా అంటాము. ర్యాండమ్ వేరియబుల్స్ అంటే ఏంటంటే ఒక రియల్ వాల్యూడ్ ఫంక్షన్స్. రియల్ టైమ్ ఫిజికల్ ఫినామినా ఆల్ ఆర్ నాన్ న్యూమరికల్. సో assigning numerical values to those non-numerical outcomes is a random variable. అందుకే అంటారు, ఏమంటారు, a random variable is a real valued function. A random variable is a real valued function that assigns, ఏం చేస్తుంది అది, that assigns numerical values to non-numerical outcomes. Right? ఎవరికి ఇస్తుంది? న్యూమరికల్ వాల్యూస్ టు non-numerical outcomes. రియల్ టైంలో అన్ని non-numericalే కదా. ఎండ ఎంత ఉంది, కొంత ఉంది అంటాం మనం. సో we cannot exactly say what is the quantity that is going to be measured. సో ఒక ర్యాండమ్ వేరియబుల్ అంటే అలా డిఫైన్ చేస్తాం మనం. ర్యాండమ్ వేరియబుల్ అంటే ఒక ఫంక్షన్. ఆ ఫంక్షన్ ఏం చేస్తుంది, రియల్ టైంలో వచ్చే అన్ని non-numerical outcomes కి వాల్యూ ఇస్తుంది. సో వాల్యూ ఇచ్చేదాన్నేమో we call capital letter, we use capital letter. Okay, who is assigning values? They are given capital letters x comma y comma. ఇవేంటి వాల్యూస్ ఇచ్చేది ఫంక్షన్ that is assigning values, right? Function that is assigning values. అవునా? ఓకే. ఇది మరి ఏ వాల్యూస్ ఇస్తుంది? ఆ ఇచ్చిన వాల్యూస్ మనం ఆల్వేస్ స్మాల్ లెటర్ వాడతాం. వాట్ ఎవర్ వాల్యూస్ that were assigned, they are going to be using small letters. Hope clear? Random variables are denoted by capital letters and values given by random variables are denoted by small letters. అర్థమైంది అనుకుంటా. Random variable is a real valued function that assigns numerical values to non-numerical outcomes. So classification chala undi. Continuous random variable, discrete random variable, mixed random variable. That is the classification of random variables. So ee lecture lo avanni important kaadu. Mana goal enti PTSP ela easy ga chadavali. Ante important in PTSP lo probability theory and stochastic process lo properties important. So mana goal ee lecture ku vacheppadiki only how to remember the property statements easily. సో ఏ ప్రాపర్టీ స్టేట్మెంట్ చూద్దాం ఈ లెక్చర్ లో మనము? డెన్సిటీ ఫంక్షన్, డిస్ట్రిబ్యూషన్ ఫంక్షన్ చూద్దాం. ఓకేనా? సో మనం ర్యాండమ్ వేరియబుల్ గురించి మాట్లాడుతున్నాం కదా. ర్యాండమ్ వేరియబుల్స్ అనేవి సింగిల్ కావచ్చు, మల్టిపుల్ కావచ్చు. దే కెన్ బి. ఓకేనా? ర్యాండమ్ వేరియబుల్స్, సమ్ ఎక్స్పెరిమెంట్ సింగిల్ ర్యాండమ్ వేరియబుల్. We need only description of one value. In some other cases, we use multiple, can be 2, can be 3, or any. Right? Based on the experiment, మీరు ఏం పని చేస్తున్నారు, మీరు ఏది మెజర్ చేస్తున్నారు, ఎక్కడ మెజర్ చేస్తున్నారు, ఇవన్నీ కన్సిడర్ చేసుకుని ఒక ర్యాండమ్ వేరియబుల్ సరిపోతుందా, మల్టిపుల్ ర్యాండమ్ వేరియబుల్స్ కావాలని మనం డిసైడ్ చేస్తాం. అర్థమైందా? హోప్ అండర్స్టాండ్. Suppose say what is the meaning of multiple random variable? That measurement, that experiment involves number of parameters. Suppose I am measuring pressure at some height. Say, what is the pressure? What is the height? Example. Then I am measuring the temperature. Say, here you are measuring temperature. At what height you are measuring temperature? At what time you are measuring temperature? Because temperature is not fixed in time. Temperature is not fixed in height, etc. So if the experiment involves multiple parameters, we use multiple random variables. If experiment uses only one parameter, single random variable. So మన కాంటెక్స్ట్ ఏంటి? డెన్సిటీ ఫంక్షన్, డిస్ట్రిబ్యూషన్ ఫంక్షన్ కదా. సో ఈ లెక్చర్ లో సింగిల్ ర్యాండమ్ వేరియబుల్స్, 2 ర్యాండమ్ వేరియబుల్స్ ఉంటే ఎలా మనం వాటిని గుర్తుంచుకోవాలి, అది ఆబ్జెక్టివ్. అర్థమైంది అనుకుంటా. చూద్దాం. సో మన గోల్ ఏంటి? We want to talk about density function. Notation ఏంటి? డెన్సిటీ ఫంక్షన్ స్మాల్ ఎఫెక్ట్స్ ఆఫ్ ఎక్స్. ప్యారలల్ గా గుర్తుంచేసుకోండి. స్మాల్ ఎఫెక్ట్స్ ఆఫ్ ఎక్స్ రిప్రజెంట్స్ probability density function of random variable x. Then capital Fx of x indicates probability distribution function of random variable capital X. Right? Small fx of x density function, capital Fx of x distribution function. For what? There is a single random variable. Right? If my experiment involves only one random variable, one physical phenomena, this is sufficient. So sometimes now I need multiple random variables. One random variable is not sufficient to describe my experiment. Then I need multiple. So suppose say I am using 2 random variables. Say I am calling them as xy. So in such a case, fxy of x comma y. What is this? Capital X. No, this represent joint probability distribution function. Remember, capital F means distribution, right? So this represents joint distribution function. Fxy. And similarly, I use small fx, fxy of x comma y. What it means? Small f. So how many random variables are there? Is it 1? No, 2. Rendu unnai kada. So join. One random variable, probability density function, probability distribution function. 2 or more random variables, probability joint probability distribution function or joint probability density function. Kada. So mana goal enti? Now let us go with the properties of these two simultaneously. Right? First we discuss about, no, we won't prove anything now. Remember, the objective of this lecture is to not prove all properties. First of all, let us remember the property statements parallelly. For one random variable, what property exists? No, same properties exist for multiple random variables. Adi random variable ki ఏవైతే ఉంటాయో అవే పక్క పక్కనే రాసేసుకుంటే ఈజీ. So first, let us go like this. మనం ఏం చేద్దామంటే ఇలా చేద్దాం. First, distribution function properties చూద్దాం. So parallel గా పక్కనే ఒక పెన్ పేపర్ పెట్టేసేసుకొని ప్రాక్టీస్ చేసుకోండి. Distribution function. Say one random variable means simply we call probability distribution function. Two random variables ఉంటే ఏమంటాయి అనుకున్నాం మనం? Joint probability distribution function అనుకున్నాం కదా, చూద్దాం. Okay, Arena, let us go. Right, start. First, distribution function. Now the difference, let's just kondi. What is this? Unkondi, what is this? Small fx of x. Ennunnai okate undi. So probability distribution function. Ikkada chuddam ee pakkana. Fx y of x comma y. How many random variables are there? X and y. Two variables are there. So this is joint. I put in here. This is joint probability distribution function. This is simply probability distribution function. Now let us start the properties. First one. What is first property? Fx of minus infinity equal to 0. We prove them later. గుర్తుంచుకుందాం మనం. ఒక random variable కదా, fx of minus infinity 0. దీని counterpart ఇక్కడ ఏమొస్తుంది? Distribution ఇక్కడ joint function అయితే ఓకే చూద్దామా? Right. So the objective of this lecture is to make them not a comparison. Don't mistake. It's not a comparison. This is the property of probability distribution function. This is the property of joint probability distribution function. The meaning ఏంటి? Fx of minus infinity 0 అంటే ఒక random variable ఎప్పుడు కూడా minus infinity value తీసుకోదు. Clear? ఒక random variable ఎప్పుడు minus infinity తీసుకోదు. ఇక్కడ చూద్దాం ఎన్ని random variables ఉన్నాయి? రెండు కదా. So two random variables can never take a value of minus infinity. ఇది 0. Whatever na మనం ఒక ఎక్స్పెరిమెంట్ పర్ఫార్మ్ చేస్తున్నామంటే ఇన్ మైనస్ ఇన్ఫినిటీ వాల్యూ ఇస్తామా? ఇవ్వం కదా. కాబట్టి ఆ ప్రాబబిలిటీ ఉండదు. అదే మీనింగ్. We never assign a value of minus infinity to any experiment. కాబట్టి 0 సరిపోలా. Minus infinity 0, fx of minus infinity comma minus infinity or minus infinity comma y or x comma infinity 0. అయిపోయింది ఫస్ట్. సెకండ్ చూద్దామా? ఓకే, దిస్ ఈస్ ద ఫస్ట్ ప్రాపర్టీ. సెకండ్ ఏంటి? fx of infinity equal to 1. What is the meaning of fx of infinity? Actually, probability distribution function is cumulative. What is fx of x? Fx of x gives the probability of random variable taking a value up to. So cumulative. So what is the meaning? Cumulative properties. So up to infinity, if I am going on adding, it will be equal to 1. That is the meaning of this statement. Okay, na? Ikkada kodama. So how many random variables are here? Two random variables. Fx y of infinity comma infinity equal to 1. See how easy. Here one random variable, here two random variables, right? Hope it is clear. Now comparison here on ఏమైంది? Minimum value 0 అయింది, maximum value 1 అయింది. అవునా కదా? ఈ మినిమం వాల్యూ 0 ఎందుకని? మైనస్ ఇన్ఫినిటీ. దానికంటే తక్కువ వాల్యూ ఉండదు కదా. సో మైనస్ ఇన్ఫినిటీ is the lowest one on the left hand side, negative side. So fx of minus infinity 0, lowest value. Fx of infinity, highest value, positive side. So simple గా దాని నుంచి చూసుకుంటే మనం 0 less than or equal to fx of x less than or equal to 1. Minimum value is 0, maximum value is 1, right? That is for a single random variable. Now see here, same case. Maximum value is 0, maximum value is 1, minimum value is 0. గమనించారా ఎంత ఈజీ అయిపోయిందో? సో ఇలా మనం చదువుకునేటప్పుడు ఒక లాజిక్ ప్రకారం చదువుకుంటే ఎంతో ఈజీ అయిపోతుంది. Clear? Next వెళ్దామా? We go for next property, right? Property statement number 4 for this function. Each function, hope it is clear. Left hand side, we are talking about probability density function, distribution function properties. Right hand side, we are listing the properties of the joint probability distribution function. No confusion, please. Hope understood. Examination lo vadu list the properties of probability distribution function means you have to write this. If it is asked joint probability distribution function, we have to write this. Clear? Joint probability distribution function. It is joint. It is simply probability distribution function. Sometimes దీన్ని ఏమంటారు, దీన్ని మనము cumulative అంటాం. Cumulative distribution function. Confusion లేదుగా. ఒక random variable అయితే left hand side, two random variables అయితే right hand side. ఓకేనా? Next, the statement ended actually density function cumulative kada. So it is an ever increasing function. ఏమంటాం ఇక్కడ మనము fx of x1 is less than or equals to fx of x2. ఎప్పుడు? If x1 is less than x2, the probability of value taking up to x1 is less than probability value taken up to x2. This is for a single random variable case. Come this side. How many random variables are here? Here there are two random variables. So what we say? Like this: fxy of x1 comma y1 is always less than or equal to fxy of x2 comma y2. ఎప్పుడు condition ఉంది, if x1 is less than x2 comma y1 is less than y2. See how easy. Simultaneously, don't worry about derivation. Prove చేయగలమా చేయలేమా తర్వాత, ముందు స్టేట్మెంట్స్ రాసామనుకుంటే ఈజీ కదా. This is about fourth property. Then we continue with the remaining properties. Fifth one. So, fifth one. Probability of x1 less than x less than or equal to x2 equal to fx of x2 minus fx of x1. Okay, clear? So this is the fifth property. Okay. ఒక ఇంటర్వ్యూలో ఒక ఇంటర్వెల్లో ఒక వాల్యూ ఉండే పాసిబిలిటీ ఎంత అంటే అప్పర్ వాల్యూ వెళ్ళే పాసిబిలిటీలోంచి లో వాల్యూ పాసిబిలిటీ తీసేస్తాం మనం. Okay, come this side. How many random variables here? 2, no? So we have mentioned 2. Probability of x1 less than x less than or equal to x2. Okay, comma. Wait. 2 variables now. Comma. y1 less than y less than or equal to y2 equal to fxy of x2 comma y2 plus fxy of x1 comma y1 minus fxy of x1 comma y2 minus fxy of x2 comma y1. ఇది కొంచెం డిఫికల్ట్ అనిపించవచ్చు కానీ ఈజీనే. So these are the 5 common properties mostly for probability distribution function of one random variable and 2 random variables. Okay, so coming to this, we have one property extra, marginal functions అంటాం దీన్ని. ఒక ఫంక్షన్ ని మనం ఇంకో ఫంక్షన్ దగ్గర నుంచి డిరైవ్ చేస్తే definition కాకూడదు. fx of x now I am writing is not the definition function. Any function, if estimated by using another function, we call them as marginal functions. So fxy of x comma infinity, this is called as marginal distribution function of x. And similarly, fy of y equal to fxy of infinity comma y, infinity comma y. This is called as marginal distribution function of y, because here x is limited value, y is infinity. So what is the common area? X, no, that is y fx of x. ikkada y small value, x infinity value ante enti చూద్దాం ఒకసారి. ఈ ప్రాపర్టీ తర్వాత మనం ప్రూవ్ చేద్దాం. Now our objective is not to prove the properties, so మనం let us not go for that. దానికి వెళ్ళొద్దు, వాళ్ళు భయపడిపోతారు. సో ఒక తీసుకుందాం ఇలా. ఇది x వాల్యూ ఫైనల్ కొనుక్కోండి. దెన్ ఇది y వాల్యూ. ఓకే, the minus 10, 0, 10. This is 0, 10. So fxy of x comma infinity and t joint event, joint probability, right? In other words, probability distribution function indicates joint probability. So what is the common area? X kada. Kabatti fx of x indi. Alage bypod. See how easy the property statements for remembering. Put both side by side. Properties of distribution function, properties of joint distribution function. You can remember that, right? So now in the same velocity or same speed, let us go with the probability density function. Probabilities. Let us see. Okay, density function. Probability density function. If a single random variable is existing, we call it as a probability density function. If there exist multiple random variables, we call it as a joint density function or joint probability density function. Joint probability density function. అర్థమైందా? ఇక్కడ ఏం రావాలి? సింపుల్ గా అది probability density function. Probability density function. Notation గుర్తుందిగా. Density function small fx of x. Distribution function capital Fx of x. Okay. Remember this. No? So left hand side we talked about single random variable. Right hand side we talked about multiple random variables. Clear? Objective method. We want to remember the property statements. We prove them later and some other time. Okay, same manner as in the case of previous one. Let us put some separation. First property. Probability density function is always a positive quantity. Negative value no possible. Right? Two random variables. Now see how easy. Two random variables. Joint probability density function is always a non-negative quantity. First statement. Always positive. It should not be negative. If it is negative, it is not valid. Second one, area under the probability density function is always unity. Area under the probability density function always unity for single random variable. Suppose I'm having two random variables. So two integrations. One random variable, one integration. Two random variables, two integrations. So area under the joint probability density function is unity. That is what I am saying from the beginning. If you know the properties for one random variable, you can know the properties for multiple random variables. One random variable, one integration. Two random variables, two integrations. One random variable, one differentiation. More random variables, more differentiations. Okay? Okay, let us proceed. We can obtain the distribution function from the knowledge of density function like this. Fx of x capital equals to minus infinity to x fx of x dx. Clear? Density function, distribution function has some relationship. Distribution function is the integral of density function. Density function is the derivative of distribution function. Hope that is remembered. Now this is for multiple random variables. No, two random variables only we are considering. Two random variables means two integrations. So similarly, minus infinity to y, minus infinity to x, fxy of x comma y, dx dy. What the property means? If you know the joint probability density function, you can estimate the joint probability distribution function. Similarly, if you know the probability density function of one random variable, you can estimate the probability distribution function. Okay, right. Let us proceed further. If you know the, okay, then fourth one, probability of x1 less than or equal to x2 equal to area x1 to x2 fx of x dx. What is the probability of a random variable taking a value between two given values is integral x1 to x2 fx of x dx, right? Come here, this side. So fourth one is two random variables, no, two conditions, x1 less than x less than x2, comma, y1 less than y less than or equal to y2 equal to two integrations, right? So, okay, x1 to x2, y1 to y2, fx y of x comma y dx dy. So put these properties side by side. You can prepare properties for one random variable and two random variables simultaneously. Only equations matrame kaadu. Statements also, derivations also. If you know the derivations for one random variable or one distribution function, you can simply go for joint distribution function or joint density function. So, okay. Now we add my extra properties, right? Marginal. I'm going for marginal properties of this. Okay. So let me add more. First one, 5. So if I know joint probability density function, I can estimate the marginal density functions. What is the meaning of marginal? Told. A function estimated from other functions. So minus infinity to infinity fx y of x comma y dy, right? Minus infinity to infinity fx y of x comma y dy. And similarly, ikkada gamaniste easyga x ki y ravali, y ki x ravali. fx y of x comma y dx. This is what estimate x. These two, fifth property and sixth property, are only for joint probability density function. Sometimes the problems are joint density function will be given and you will be asked to estimate the density functions individually. Okay. Similarly, we see this joint probability density function used to estimate the marginal functions. Fx of x equals to minus infinity to x minus infinity to infinity fx y of x comma y dy dx different. Okay. Similarly, fy of y equal to minus infinity to y minus infinity to infinity fx y of x comma y dx dy. So in this manner, if you plan accordingly, preparation will be little easy. You can easily go through the derivative part also once these statements are understood. And by the way, I have not mentioned in the beginning because the objective is to talk about the tips to prepare. No, what is the meaning of a distribution function and what is the meaning of a density function? I have not mentioned. Fx of x, probability density distribution function. What it gives the probability of a random variable taking a value up to x. This is definition. Okay, if you take a two random variable case, fx y of x comma y, what it is called as joint probability distribution function. What it gives, this joint probability distribution function, this joint probability distribution function gives the probability of two random variables, x and y, taking values x less than x and y less than y, joint probability. Strictly speaking, joint probability distribution function gives the joint probability. So this is definition. What is the key point? Distribution function gives the probability of a random variable taking a value up to x. That is why you have mentioned probability of x less than or equal to x. Sorry, let us go for density function. What is density function? Density function gives the probability of random variable taking a value x. Random variable ఏ వాల్యూ తీసుకునే పాసిబిలిటీ ఎంత, దట్ ఈస్. అందుకే ఒక ఎగ్జాంపుల్ చెప్తూ ఉంటాను నేను. ఇఫ్ సపోజ్ నేను క్లాసెస్ తీసుకుంటూ ఉన్నా, ఈ క్లాస్ లో ఏమర్థమైంది అంటే ఆ ఇన్స్టెంట్ దగ్గర, ఎట్ దట్ ఇన్స్టెంట్ దిస్ డెన్సిటీ ఫంక్షన్, ఈ క్లాస్ దాకా ఇప్పటిదాకా ఏమర్థమైంది, డిస్ట్రిబ్యూషన్ ఫంక్షన్, రైట్? దట్ ఈస్ వై we mention less than or equal to there and only equal to here. Similar context, let us mention fxy of x comma y. What it says, it gives the joint probability of x taking a value small x and y taking a value small y. Of course, this is a capital letter. Don't worry about this. Modify it. I will. This is a joint probability density function. And let me go back. Among the properties, we have a property. This is here second property, either this or that. Area under the density function is unity. This property plays a crucial role. The advantage of this property is used to verify whether a given density function is valid or not. Generally, property statements are meant for simplifying the problem analysis. So these property statements reduce the complexity in the analysis. So what is that second property states? Second property states that area under the density function is unity. If I have two random variables, I say area under the joint density function is unity. Fx of x dx equal to 1 minus infinity to infinity minus infinity to infinity fxy of x comma y dx dy equal to 1. One random variable, we use this. Two random variables, we use this. And this property is useful in verifying whether a random variable, a density function is valid or not. But density function ichi adi valida kada check cheyalante ee vaadtam man. Okay, so small example, let you know about this problem. Example we take, something is given like this. Fx of x equal to c into 1 plus x square, where 2 less than x less than 3. Verify, okay, not verify, obtain the value of c. Question is asked like this: obtain the value of c, constant, c is a constant, c, such that obtain the value of constant c such that fx of x given density function is valid. గుర్తుంచుకోవాలి, అది సింగిల్ ర్యాండమ్ వేరియబుల్ కావచ్చు, మల్టిపుల్ ర్యాండమ్ వేరియబుల్ కావచ్చు. ఇంకో ఇలా అడగచ్చు, fxy of x equals to k into 1 plus xy. What is difference? Same, no? Okay. So what we have to proceed in this manner. So remember, we are talking about the advantage of properties currently. Okay. So solution. A density function is valid. A density function is valid if area under it is unity. What is the meaning of area? Area means integration, no? So let us continue. That is, proceed like this. Minus infinity to infinity fxy of x comma y dx equal to 1. Now, no, single random variable. Sorry, I have written the expression for multiple random variables. As you're talking about one random variable, let me go with example also for the single random variable. Fx of x dx equal to 1. What are the limits of x? X is from 2 to 3. What is the given function? Let us verify. K into 1 plus c into 1 plus x square, not k. Okay. Okay. It is c into 1 plus x square. C into 1 plus x square dx equal to 1. Is it clear? Area under density function is yield C. So constant outside. Okay, limits are 2 to 3. Integration of 1 is x plus integration of x square is x cube by 3 equal to 1. Clear? Area under capability density function is equal to unity is used for estimating the constants. So now what do? We substitute limits. Upper limit is 3, lower limit is 2. So 3 minus 2 plus 3 cube minus 2 cube by 3 equal to 1. Adamandi kada, anta easy. Property statements are meant for making the solution easy. Similarly, so C into 3 minus 2, 1. 3 cube, 27. 3 3s are 9, 27. 2 cube, 8 by 3 equal to 1. So C into 1 plus 27 minus 8, 19. 19 by 3 equal to 1. అంటే ఏమవుతుంది 3 22 C into 22 by 3 అంతే కదా 3 1s are LCM అంటే equal to 1. So the constant C in this example is given as 3 by 22. 3 3 then 29, 27 minus 8. Okay, 19 by 3. Verify the answers. No one then. Okay, now. So this is the advantage. Simultaneously, we are also trying to make use of the properties for problem solution, right? So this is for one random variable, right? So let me just take one more case to continue this advantage of property statements. Example 2. ఇలా ఇచ్చా నేను 2 random variables తీసుకున్నా x, y equals to 1 plus xy. X is 0 less than x less than 1. Y is 0 less than y less than 2. Limits ఏవైనా కావచ్చు. ఓకేనా? అప్ టైం కాన్స్టెంట్ k. అప్ టైం కాన్స్టెంట్ k. అర్థమైపోయింది. మీకు చేసేసుకోగలరు. కాన్స్టెంట్ k. ఎలా? A density function is valid if area under the, how many random variables? Rendu kada. So area under the joint probability density function is equal to int. 2 random variables, 2 integrations. 1 random variable, 1 integration. Now substitute them. Okay. So this manner we can easily 0 to 2, 0 to 1, k into 1 plus xy dx dy equal to 1. First one, what we do? 0 to 2, k constant outside, limits are 0 to 1, 1 plus x square. Okay, limits are going to be changed here. I mean 0 to 1, integration of 1 is x, integration of xy is x square by 2y dy equal to 1. Substitute. Upper limit is 1. So 0 to 2, upper limit is here 1 minus 0, then plus lower, okay, upper limit is 1, lower limit 0. Here also 1 minus 0 into y by 2. Is it clear? X value is 1 no. So 1 square is 1. So what is the dy equal to 1? Continue here. So k into, we continue same manner here. What we have got till now? So k integral 0 to 2, 1 plus y by 2 dy equal to 1. Continue. K integration తెలుసు కదా, ఆయక్కర్లేదు అనుకుంటున్నా. Okay, 0 to 2, integration of 1 is y, integration of y is y square by 2, rd2 is there, 2 into 2 is 4 equal to 1. So this is equal to k into 2 minus 0 plus 2 square minus 0 by 2 square equal to 1. 2 into 2, 2 square. 2 square, 2 square. Plus 2 plus 1 is 3. 2k equal to 1. So k equal to 1 by 2k. So this is 2 plus 1, 3. 3k. 3k equals to 1. So k equals to 1 by 3. So in this manner, the property statements have related examples. Sometimes I may give you a joint density function and ask you estimate the marginal density functions. So those expressions must be known to you in well advance. Okay, so let us take a small pause here and go for the other properties of the in our course. Well, now let us move to how to remember the property statements of power spectral density. Okay, so there are two types of power spectral densities. One is power spectral density. Second one is cross power spectral density. If you have only one random variable, we'll simply call power spectral density. And if you have two random variables, we call cross power spectral density. This is represented as Sx of omega. This is represented as Sxy of omega. Clear? Now let us see how to remember these easily. Okay. So first one. Sx of omega is always greater than or equal to 0. Our spectral density is always positive. From this side, Sxy of omega or Syx of omega equal to 0 if random processes x of t and y of t are orthogonal. So our objective is to remember the properties easily. This is greater than or equal to 0. Sx of omega. Power spectral density is always positive quantity. Coming this side, across power spectral density is equal to 0 if they are orthogonal. మర్చిపోవద్దు మన ఆబ్జెక్ట్ ఇక్కడ వీఆర్ నాట్ ప్రూవింగ్ ప్రాపర్టీస్ మనం ప్రూవ్ చేయడంలో హౌ టు రిమెంబర్ దమ్ ఈజీలీ ఓన్లీ అవర్ టాస్క్ నౌ కరెంట్లీ సెకండ్ వన్ power spectral density is an even function. Sx of omega equal to Sx of minus omega. Power spectral density is PSD. Power spectral density is an even function of omega. This is for PSD or auto PSD. Coming to this side, our complete function is not an even function. Okay, real part of Sxy of omega అంతేకాదు r as well as real part of Syx of omega are even function of omega. Okay, here also there exists even symmetry. The difference is complete function is not even function, only real part. Even function even function of omega. Even real part of the cross power spectral density is even function of omega. So under this case, we have multiple properties. Similarly, under symmetry property, we can say, I think this is a second one, right? So we have third property also here. Third one, imaginary part of Sxy of omega as well as imaginary part of syx of omega are odd functions of omega or odd functions of omega. So this is one more property to remember with reference to symmetry property, right? Okay. Now let us continue here also. The same manner as we are discussing now. Left hand side is PSD properties. Remember, this is not a comparison. This is only to remember them easily. Third one, if x of t has PSD Sx of omega, then dx of t by dt or x of t dot has PSD, we write like this. Sx dot of omega equal to omega square into Sx of omega. This is the third one. Let's come this side. Okay. Now they are not same, but some way compared. When x of t and y of t are uncorrelated and stationary, okay, uncorrelated and stationary, then Sxy of omega equals to 2 into pi into x bar into y bar into del of omega. Okay, right. This property number is 3. It's not 2. It is not 3. It is 4. Why? Because under symmetry we have 2 properties. So correspondingly, this property is 4th one. And mostly among all the properties, the most important property is one more thing here is there. Okay, I think we have to remember that carefully. What we say here, power spectral density and time average of autocorrelation function form a Fourier transform pair. Power spectral density and time average of autocorrelation function form a Fourier transform pair. Here, cross power spectral density and time average of cross correlation function form a Fourier transform pair. If x of t is stationary, WSS wide sense stationary, then Sx of omega automatically forms a Fourier transform pair with autocorrelation function. This is called as Wiener-Heinchen relationship. Here also, if x of t and y of t are jointly wide sense stationary, if x of t and y of t are jointly wide sense stationary, then Sxy of omega forms a Fourier transform pair directly with autocorrelation function. Clear? The property statements. In addition to them, we have few more here. Sx of omega, power spectral density is always real, always positive quantity also we have told. And one point, remember, గుర్తుంచుకోవాల్సింది ఏంటంటే ప్రాబ్లమ్ చేసేటప్పుడు sometimes if we asked, verify whether the given power spectral density is valid or not. In those cases, we use these properties. Okay, we'll choose that. What is the advantage of these property statements? Let me just mention on, okay, whenever we were asked, okay, verify whether, example, with reference to properties, verify whether given power spectral density, verify whether given power spectral density is valid or not. Sx of omega equal to mod of omega by 1 plus 6 omega plus omega power 4. So what are three conditions for a power spectral density to be valid? Generally, three conditions are needed. First one, it must be always a positive quantity. Second one, it must always real. It should not contain any imaginary part. And third one, it should be an even function of omega. So if you observe the given power spectral density mod omega by 1 plus 6 omega plus omega power 4, it seems it is real. There is no imaginary term because of mod. It may be greater or equal to 0, but third condition is there now. See what it says. Third one. Let us verify that. Is the given power spectral density is even function or not? Let's substitute mod of minus omega by 1 minus 6 omega plus minus omega power 4. So this is mod of omega 1 minus 6 omega plus omega power 4. It is not equal to Sx of omega. So it is not an even function. It is not an even function of omega. So it is not valid. So in this manner, the advantage of problem statements is for solving problems. And while preparing, take care how to easily prepare your plan. Okay, so we continue further in the upcoming lectures. Hope this way of making the properties remembered is acceptable to you people. And before we wind up this, what is required is we need to practice the properties.